Okay, continuing on with solving simultaneous equations, and just a reminder of what this concept is. This is if you have two lines, we're looking for the point where those two lines intersect, like that red point there. So our first algebraic method is called substitution, and depending what your equations look like, we'll tell you what method to use. So with substitution, we kind of have to get one of the letters on its own. So we want one of these equations just to become y equals or just x equals. And this top one looks very good. So let's work with that. Y take 2x equals 1. So this is equation 1. So I want to be rearranging this to get just y on its own. Now when you rearrange equations, you're allowed to add things to both sides as long as it's the same thing, or take things or times or divide things to both sides. And we want to get rid of this take away 2x here because we want just y on its own. So basically what we're looking for is the opposite of take 2x, which is plus 2x. So we're going to do that to both sides and we'll see what happens. When I say both sides, I mean both sides of this equals sign here. All right, so y take 2x plus 2x. These things are going to cancel off. So I'm just left with y on that left-hand side, which is basically the reason why I did this. On the right-hand side, I've got 1 plus 2x. Great stuff. Okay, next thing we're going to do is take all this into equation 2, and we're going to substitute this y value in, which is why this is called substitution. Okay, 2x plus 2y equals 8. And then we're going to substitute in this value for y, this 1 plus 2x. 2x plus 2. Now I'm going to put in the y value and make sure you chuck that in brackets. 1 plus 2x equals 8, just like that. Now this looks a heck of a lot worse than what equation 2 first looked like, but I promise it's better. The reason is we actually don't have any y's in this equation. It's all just x values, which is really good news for us. Okay, so one thing you're going to be using a lot in substitution is the distributive law, or maybe you might have heard it as FOIL before, but it's basically how do you deal with these brackets. So to deal with a bracket like this, you want to pull the 2 into each bit of that bracket and see what happens. So let's simplify this equation down. 2x here just stays as 2x. That doesn't change. Here, the first term we're going to get is 2 times 1, which is 2. The next term is going to be 2 lots of 2x, which is 4x. Now that's the whole bracket dealt with, and you just get rid of the brackets at that point. Equals 8 still. Now we're going to do something called collecting like terms. So we're going to look for everything that is sort of like in the same form. So any numbers on their own will collect together, and any things with just x's will collect together. So I can already see 2x and 4x are going to merge together to make 6x. And I've still got this plus 2 hanging out on the end there. Cool. So now we're in this equation. You might be able to spot straight away that if x was 1, it would solve this, because 6 times 1 plus 2 would give you 8. But let's do this formally. So basically, we want to unravel this to get x on its own. So how do I do that? Well, I'm going to undo everything that's been done on that left-hand side. I started with x, and then I times by 6, and then I added 2. We look at that very last thing, which is add 2, and we're going to do the opposite, which is take 2 to both sides. So over here, I'm left with 6x because they cancel out. And I'm going to get 8 take 2 on the right-hand side, which is 6. Now, we're going to do the same thing. How do I get x on its own? Well, I times by 6. What's the opposite of timesing by 6? It's dividing by 6. So let's do that. So the 6 and the 6 will cancel off, which is exactly what we wanted. X is going to be 6 divided by 6, which is 1. Cool stuff. Okay, now that we know x is 1, we haven't finished solving this because we need to figure out what y is. So let's pick any one of our equations and we're going to sub in x equals 1. So x equals 1. Let's just pick, I'm going to go with equation 1 because it looks kind of nice. So y take 2x equals 1. So this will become y take 2 times 1 because x is 1 equals 1. So that's y take 2 equals 1. And then if you want to solve that, you can add 2 to both sides. Now, I know it can seem like a bit of overkill for me to formally solve this equation by adding 2, even though you might be able to see that y should be 3. But it's really important to get in the habit of that, so we know how to do it for the more complicated ones. y equals 1 plus 2, which is 3. Great stuff. So our intersection point is going to be x equals 1, y equals 3, or in other words, that's a point 1, 3 is our intersection. Okay, so now that we know 1, 3 is our intersection, we should probably double check that this is right. And the best way to do that is on something like Desmos, mainly because you can't graph this one on your calculator, given that the bottom one doesn't start with y equals something. So let's have a look. Our two equations are y take 2x equals 1. And our next equation is 2x plus 2y equals 8. And if we look at where they're intersecting, you just click on that there, 1, 3 should match what we said for the intersection point, which is wonderful news for us.